friends, Namaskar. I am B.J. Nadavade, Associate Professor in Electronics, Right Section Samsthas, SGM College. The topic I want to cover is number system from digital electronics or digital fundamentals. Different number systems are there. Number system is a language. It is used to share numerical, logical as well as arithmetic information. As far as digital electronics is concerned, the important number systems are decimal number system, binary number system, octal number system as well as hexadecimal number system. Short we call as a hexadecimal number system. Now the number system first we will going to study is a decimal. Actually it is a familiar number system. It is used all over the world. Everybody in the world working with decimal number system. Easily one can understand, one can interpret the decimal number system, no doubt. But still we will have to study technically the decimal number system. The decimal number system, it uses 10 basic symbols. The symbols are 0, 1, 2 up to 9. These symbols are used in decimal number system. It uses 10 symbols, total 10 symbols, and that's why it is known as a decimal number system. Its base is 10 or its radix is, we call it as a radix or base, it is a 10. These symbols are used in proper sequence. It starts with 0, then 1, 2, 3. These symbols are used in proper sequence up to 9. And every symbol is given a specific meaning. 0 means nothing, 1 means something one is there, 2 means two things are there, or two events are there. In this way, 9 means 9. So it was decided that every symbol has given the proper meaning and proper sequence is maintained in this symbols. Now these are the 10 symbols, no doubt we count up to 10. How we count progressively in the decimal? It is important. What is the next number? How we count in decimal or how progressive counting is done in the decimal, we must study. Even we know it, we are familiar with, still the student must study the decimal counting first. Now how we count in decimal? We start with 0, 0, 1, 2, we go up to 9, no doubt, no problem. But after 9, which is the next number? So after 9, how the next number comes? We have used all these symbols. We complete this column. That's why reset it. Okay? And increment the next column there. And that's why the next number is 1. When all the symbols are used, reset this column and increment the next column towards the MSB side by 1. So it becomes 1. Then what is the next number? It comes 1, 1 because not necessary to change this one. All the 10 symbols, use all these 10 symbols here again. So it becomes 1, 0, then 1, 1, 1, 2, 1, 3, 1, 4, go up to 1, 9. Again we use all these 10 symbols. After that, after 1, 9, the next number is again reset this column, so it becomes 0 and increment the next column by 1. So it becomes 2, 0. Then 2, 0, 2, 1, 2, 2, go up to 2, 9. Again at the 9, reset this column, so it becomes 0 there, increment next. So the next number is 3, 0. In this way, we go up to 9, 9. After 9, 9, what is the next number? After 9, 9, what is the? Here we use all these symbols here. We use all the symbols in next column also. And then reset this column, and increment this number. So next number is in this way, next number is 1, 0, 0. Then 1, 0 maintain as it is because we have all these 10 symbols, use them. So 1, 0, 1, 1, 0, 2, 1, 0, 3, go up to 1, 0, 9. Again reset this column, increment this, and this becomes 1, 1, 0. In this way, 1, 1, 0, 1, 1, 1, 1, 1, 2. In this way, we count progressively in the decimal number system. The example of decimal number systems are, suppose 256 is the decimal number. It is represented by the subscript 10 after that number. So 256 is the decimal number. 45.67. This is also the decimal number. So these are the examples. In this way, with decimal numbers, this fractional number is there. Important thing is that in the decimal number, every digit has its positional weight. This is very important. Suppose number is 222. All the symbols are same. Still, each symbol has the different meaning, different positional weight. 2 has positional weight only 2. 2 into 10 raised to 0. This has positional weight 2 into base raised to 1, 10 raised to 1. This has positional weight 2 into 10 raised to 2. Even fractional number, suppose 47.58. The 7 has positional weight 7 into 10 raised to 0. This has positional weight 4 into 10 raised to 1. In this way. And this 5 has positional weight 5 into 10 raised to minus 1. This 8 has positional weight 8 into 10 raised to minus 2. In this way, every digit has the positional weight. Suppose the big number, suppose 5866.37. Here 6 has positional weight 6 into 10 raised to 0, 6 into 10 raised to 1, 8 into 10 raised to 2, 5 into 10 raised to 3, and here the fractional number 3 has position 3 into 10 raised to minus 1. In this way, every digit has the positional weight. So these are the important things, technical things about the decimal number system. Which symbols we are using, what is the sequence, what is the meaning of every symbol, then counting, then representation, and finally the positional weight. If we study all these things, then we can interpret any new number system, or even we can develop our number system also. Now the next number system is binary number system. Now question arises. Why binary? What is the need for binary number system? Actually, I have told you the decimal number system is familiar for us. Everybody easily working with the decimal. What is the need for new number system, that is binary? The reason behind this is that is all the digital systems. Even computer is a digital system, microprocessors, microcontrollers, calculators, these are the digital systems. And these digital systems are designed using the semiconductor devices. Important semiconductor devices are diodes, semiconductor diode, then transistors, field effect transistors, such semiconductor devices are there. These are used to design the digital systems. Without these devices, diodes, transistors, there is nothing in the electronics. So these are the important devices. They having tremendous application field, potentials. Application potentials very large for these devices we can use various ways. But it was observed that, it was studied that these devices working reliably, these devices working accurately, these devices working with high speed, if they operate, if we use these devices in only 2 states, on and off. If we operate these devices in 2 states, they are working very properly, reliably, accurately, with high speed when they operate in 2 states. So this is the important way to operate these devices on and off. Even the signal levels are also limited for this operation. Signal levels are changed only at 2 levels, high and low. Only the signal used to drive these devices having 2 levels, 2 states, high and low, and results are also in the 2 states, high and low, nothing other than this. So operation is on off. The signal levels are used high and low. 2 state signal levels are 2 state operation of the 2 states. And if we try to implement the number system for such operation, for such signals, If we use decimal, it becomes difficult because our decimal has, no doubt it is a familiar, but still it has 10 states. And here the device needs only 2 states, on, off, high, low. And for this 2 states operation, the binary number system is developed. Binary number system also having only 2 states. It uses 2 symbols only, 0 and 1. Only 2 states. So binary number system has base or radix system. The example of binary number system 101.11. This is the binary number. 1110111. This is again a binary number. These are examples of binary. So it uses only these 2 symbols, 2 digits, 0 and 1. And that's why its base or radix is 2. Now, these are the examples. Only 2 symbols it uses. How we count in the binary? We know decimal counting. In similar way, the binary number system we can count. Now, again, we start with 0, binary counting, 0, then 1. This completes the first column because we use all the symbols. Both the symbols we have 0 and 1. So what is the next number? Reset it and increment next number. So it becomes 1, 0. Again, 1 maintain there. 1 symbol is remaining there, so 1, 1. This is the next number. So start with 0, then 1, 1, 0, 1, 1. What is the next number? Because only we have 2 symbols. So reset it, and increment the next number. Again, what is the next number? 1, 0 maintain there, 1 is there. So 1, 0, 1. Then reset it, increment this number, so it becomes 1, 1, 0. In this way, we count in the binary. Progressive counting is done in the binary. This is one. Now, similar to decimal, for every number system, the positional weight is important in binary. Suppose the binary number 1011. Every digit has its positional weight. This 1 has the positional weight 2 raised to 0. 1 into 2 raised to 0 means 1. Then this 1 has positional weight 1 into 2 raised to 1. This has positional weight 0 into 2 raised to 2. And this has positional weight 1 into 2 raised to 3. In this way, every digit towards this MSB side, positional weight increases. Every digit has it. Even if the fractional number is there, 1, 1, 0, then this 1 has positional weight. 1 has positional weight 2 raised to minus 1. This one has positional weight 1 into 2 raised to minus 2. 0 has positional weight 0 into 2 raised to minus 3. And last one has positional weight 1 into 2 raised to minus 4. In this way, every symbol, every digit has a positional weight also. This is the binary number system. Binary number system. Particularly, it was developed for digital systems. And it is commonly known as a machine language. It is developed for machines, digital machines. That's why it is known as a machine language. This is an important number system as far as digital electronics is concerned. Now the next number system is octal number system. Octal. Now what is need for another number system? The binary is okay for the digital system. What is the need for octal number system? Note that we are familiar with decimal. So decimal is known as our number system. Binary is known as a machine language. Machine only recognize binary. Machine working with the binary. But what happens? The binary strings are so long, very difficult to understand. Immediately we are unable to understand or recognize the binary. We can not instantly interpret the binary because the strings are very long. And that's why some new number systems are developed. These are octal number system, hexadecimal number system, somewhat near to human being and near to machine. So new number system is an octal number system. Octal number system has base of 8. It uses base symbols, and these symbols are used from decimal. So these 8 symbols are 0, 1, 2, 3, 4, 5, 6 and 7. These are the 8 symbols used in octal. So its base is 8. The examples of octal are 3, 2, 4. If the subscript 8 is used, it is now octal number. A fractional number is there. So 43.71. This is again octal number because it uses this or 8 symbol. This is the octal number. This is the example of octal number. Now how we count in octal? This is again important. Again, in octal number system we have used this 8 symbol. The sequence is maintained. Sequence we start from 0, 1, 2. Every symbol has a specific meaning, but it ends at 7. We start. Suppose counting is to be done in octal. How we start? We start from 0. 0, 1, 2, 3, 4, 5, 6, 7. What is the next number? Because we have used all these symbols. Reset it and include. So next number is 1, 0 after 7 in the octal. So what is the next number? Not necessary to change 1 because all 8 symbols are there. So again here 1, 1, 1, 2, 1, 3. We go up to 1, 7. After that reset it and increment this. So it becomes 2, 0. So in this way the last number in 2-digit last number is 7, 7 in octal. Now what is the next number after 7, 7? No doubt reset it and increments. After that 1, 0, 1. In this way we count in octal also. So its base is that we can easily count in octal. Every symbol has given the specific meaning. So this is about the octal number system. Now the next number system is the hexadecimal number system. Hexadecimal number system, it is also developed in order to use this number system, use the number system for machine. So machine can easily interpret and we can easily interpret, we can easily working with this. That's why the hexadecimal number system. Hexadecimal number system, it uses total 16 symbols. And these symbols are selected, well-known symbols. 10 numbers are used from decimal. So hexadecimal number, hex or hexadecimal, decimal number system, it uses 16 symbols. Which are the symbols? So the 10 numbers are used. So 0, 1, 2 up to 9. These 10 numbers. And after that the alphabets are used. A, B, C, D, E and F. So in this way it uses the 16 symbols. Every symbol, the symbols are used in proper sequence. We start with 0, 1, 2, 3, 4 up to 9, then A, B, C, D up to here. No doubt, this is the sequence and every symbol has given a proper meaning also. So its base is 16 and the examples of hexadecimal number systems are 1AB, 2FE, 0.82. If the subscript 16 is used, this is for the hexadecimal number system. So these are the example of hexadecimal numbers, and note that every symbol in hexadecimal number system has positional rate. This is again important. What is the positional rate of the hexadecimal number system? This 2FE 0.80. Suppose this is the same, or take the another examples. 2A into 2A7 0.23. This is the hexadecimal. This 7 has the positional rate 7 into 16 raised to 0. It's base raised to 0. A into 16 raised to 1. This 2 into 16 raised to 2. Even this 0.2, the fractional number in hex, this 2 has positional weight. 2 into 16 raised to minus 1, 3 into 16 raised to minus 2. In this way, hexadecimal number system also its positional weight. So all these are the 4 number systems: decimal number system, binary number system, octal and hexadecimal number system. Note that the old one, very familiar, everybody working with it, with the decimal. We all know, we are familiar with the decimal. Binary, it was developed as a need of these digital systems, because to give the specific characteristics for the digital systems, for the proper working, the binary number system was developed. But these two number systems are developed for the interface, human interface with the system, because the binary, it is a machine language still. It has a long sequence, and when very long sequence we can't easily interpret. That's why the new number system, Octal and Hex were developed. Out of these four, the binary, no doubt it in the machine binary works, and the most popular number system for interface is the hexadecimal number system. Thank you very much.